Okay, good evening, everyone. We will go ahead and get started. So last time, I'm just assuming sound quality is okay for everyone. If you can kindly type a quick message in the chat room, that'll be awesome. If you guys can all hear me, okay, that is. So tonight's agenda, we're going to talk about composite data types, which is lesson 5. We're also going to look at cursors. So we'll start with thank you everyone for your response. We'll go ahead and start with what we did last time. We talked about working with control structures. And that was lesson 4. And there were considerations for using looping constructs and decision-making constructs. That's what we did in chapter. Work with decision-making constructs and looping constructs. So looking at this specifically, the main highlights were using the if statement, the case expressions, the 3 loop types, and the logic tables, also nesting loops. So let's spend a few minutes on just refreshing our memory on how each of these constructs work. When we talk about an if statement, then we basically are looking at something like this. If condition, then set of statements or action, and then else another set of statements. We can also have an else if block, which basically will make an entire statement as one large statement. And else if can essentially operate like this. So I just want to pull up a quick example of else if. If department number is 10, then bonus is 5,000. If it's 80, then it's 7,500. And for everyone else, it's 2,000. So we also talked about the case expression, which essentially uses the when then clause. And then the else clause essentially determines a default result. The value of the selector and expression essentially have to match for a specific corresponding result to be executed. So if selector is expression 1, then result 1 will be executed. If selector is expression 2, then result 2 will be executed. Something like this. We look at grade. If grade is A, then grade is excellent. If it's B, it's very good, and so on. We also talked about the 3 loop types: basic, for, and while. The basic loop is essentially a event control loop where you say loop and then provide an exit condition. The while loop is also event-oriented loop, and it looks at the while condition, and when it looks at the while condition, then If the condition is true, it carries out the statements. If the condition is false, it exits the loop. And then we have the third loop type, which is the for loop, that essentially uses, that is essentially for the counter, for counter oriented loops. When we say for counter in lower bound dot dot upper bound and loop, that essentially means, lower integer value and higher integer value. Something like this, where we say for I in 1 to 3 loop. So that runs the loop 3 times, with 1 and 3 being inclusive. That's a function of the counter controlled loop. We'd also looked at the logic for all of these expressions. I wanted to draw your attention to this table on page 416. When we talk about logic expressions, can you guys hear me okay? I think I'll just run a quick sound test with you guys just to make sure that we are on that you guys are able to hear. So that based on some of the messages that I'm looking at, you're saying the sound is on and off. I see. Let me try dialing in instead of the.
Okay, so I'm now joined by phone, and I would like to hear if you guys can hear me clearly and if the voice is better. Okay, a lot better. Okay, so what I was talking about when you guys reported I was cutting in and out, I was talking about the 3 loop types. And then I went on to say that the logic tables are shown in front, and the slide on 416 is very important because we've got AND operator, OR operator, and the NOT operator, each being used with the null value. So keeping an observation of the behavior with null with true and false when using an AND operator, OR operator, or the NOT operator is very important. And then last but not least, in this discussion, we were interested in working with nested loops. Can you guys hear me now or no? I thought I was audible to some of you, or I should be audible to all of you. Brian, can you hear me okay? I was talking about, what I was talking about is, we also talked about nesting loop, and we can use these labels that are mentioned in double angled brackets as outer loop or inner loop. So when you run, when you label the loops like this, then you can reference the loop with these statements. So when you're trying to say which loop you want to end, we can use the loop as a label. We never use the goto clause with the loop label. That's not considered good practice. So an example of such a loop would be when you're essentially putting one loop inside another. We have talked about these factors, and you guys already have assignment 4 assigned to you all, and you should be able to start that. Assignment 4 is due this coming October 18th. So tonight we are going to focus on lesson 5, which is talking about the composite data type. So working with composite data types is basically trying to use a PL/SQL record or a table. So by the end of this discussion, you guys should be able to differentiate between you guys should be able to differentiate between a record table and a set of tables. So, okay. So just before I continue, I just want to pause for a moment and make sure you guys are okay with sound quality and desktop sharing. Everyone can see the desktop and can hear me well, right? Okay, very well. So in this chapter, we're going to talk about these composite types. We can have a PL/SQL record, which is essentially like a row in an Excel sheet where each column definition is defined by a specific type, or you can also perhaps inherit the data type of the columns in a database table. So we've got a PL/SQL record. We've got also collections, and there are 3 of these that we're going to be covering. And the composite data types can use your internal components, which is like internal objects, if you will. And composite data type declarations are definitely reusable. Reusable just like variables, meaning you can once you have declared a type and you've declared a variable, just like a variable can be reused, the composite data types are also, their variables are also reused. So let's get to first the PL/SQL record. So if you want to store a row of information, then we put it into we put that into a record. And so, like I said, basically a record ends up being a group of fields, and each field has its own name. Like, so if you imagine columns in Excel, each column has a name and its respective data type. Generally, the data type of each of the columns would be scalar. Each column would be called a field, and there is really no limit to the number of fields that you can have. When we are declaring a variable, we are using not null and default keyword for var declarations. We can do that for each of the columns in the PL PLSQL record. So the syntax that would be used would be this right here. We're actually declaring a type. So if we declare a type, we are not allocating any memory. We would be just declaring the data type, and when we make a variable of that type, then memory would be allocated. In a type declaration, we can have the type name, and we indicate is record as keywords, and then we can provide a field declaration with a comma operator. So this basically means we can have as many fields as we need. And then when we say identifier type name, then this type name declares a variable of this type. When we declare each field, then we end up using this syntax right here. So we say field name, field type. We have percent type or percent row type as options in case we wanted to inherit the data type of a column, or we wanted to simply use the data type of an entire row. The not null value and the default expressions both apply. We can indicate the value to be not null or provide the default expression. So when a variable is declared, a default value may be given. So this is how a PL/SQL record is created. So we create a type, emp record type, and we say is record begin and end. So the type declaration is basically all this syntax. So we have emp record type, and then we have is record with 3 columns, last name, job, and salary. And then we take the a variable name we create of type emp record type. So this statement, the last statement right here, actually is the one that that would allocate memory for based on the record definition. So advantage of declaring a record is that you're able to capture more information in a variable. So if you're trying to bring out a row of information for massaging some data on, then this is a perfect way of being able to look at it. So composite data type, this is the first one that we are looking at, and this essentially will bring in the guys. Can you hear me? Going, and I appreciate your input because we are online, so sound quality is mainly very important. So this is how a variable of we basically can end up creating a record structure with multiple fields and populate values. In the one we created, we had 3 fields: ID, last name, and the job ID, and those are added as a record, and we can use this to store data temporarily in a stored procedure while we are processing the data. Using a percent row type declares a variable based on a table or a view. So if I have employees table with 8 or 9 columns, if I wanted to create a variable by simply using the using all the columns in the employees table, then I can append %row type in my variable declaration to make that. So imagine the employees table having all these columns, right? So when we create, so we don't have to do a type declaration because the table columns are already declared. So if I go in and I simply say table name %row type, then we basically are looking at this entire, table definition right here and making an emp record of that will contain ID, first name, last name, email, and so on. This makes our life a lot easier by using that shortcut, if you will. So this is kind of the syntax for we give a variable name followed by the reference of a table %row type. And then when we have to refer to the properties of the record, we can go record name dot field name. So in this case, we will say emp record dot commission % and set a value or read a value. So when we end up doing such a declaration, the biggest advantage is maintainability. We don't have to know all the column names in the table. We can simply we don't have to know the column names. If the column names change and we were to run the procedure again, it will essentially inherit the new table structure because we often end up adding and removing columns. The %row type is also specifically useful when you are using select into. So like we are taking up a bunch of data, and what we're going to do is we're going to put it in into a row. So let's have a quick look at a code snippet on how this would in fact be useful in the real world. So let's say we wanted to make some changes into the database. So as you can see, and again, to answer the question in the chat room, Catherine, you can see that the declaration, you would basically skip the type definition completely. And you can just say %row type, and that makes EMP rec becomes a record of type, employees %row type. So you look at all the columns that are in the employees table, and you're going to go ahead and use all the column names and their data types for the record declaration. Does that make sense? So we have got that record, and so this next statement is very important. When we say select star into row EMP, we are saying let's select all the column data into this one record. But we are interested in only one record because we are going to give this where clause with the specific employee ID. And then we're going to take the value selected in employee record, and we're going to do an insert into another table which apparently has similar column names as the employees table. And what I would request you to notice here is that we are using each of the columns in the record for writing the data into the retired ENPS table. So basically, emp record here is acting as a temporary store for data as we take data from the employees table and put it into another table. So of course, once the insert is done and the data is committed, when we do a select, it will show this data. Okay, using %row type. So the next thing that is of importance is the index by tables. The index by table is an object in PL SQL, and the goal here is that you can have a bunch of records in a table, but you can have one column that acts as your index, and the columns that are in the index by table can be either one value or more than one value per row, and it can increase in size dynamically. You can have an index by table of 1,000 records or 5 records, but you have to define that size. You define that size as you end up declaring the identifier of that type. So here is an index by table example. So the way the documentation is given to you here, folks, is we first look at the kind of structure of the syntax. So we're also doing a type definition like we were for a record, and we would say type name is table of. So we don't say is record of this time, we say is table of. And so we end up specifying column type, and so we are basically declaring either a column type, or we can do a table %row type like we did last time. And then in the end, we can say index by binary integer. So in this case, the example you see here is it's a index by table of all the employee names. So we give that name, employee name table is table of employees last name. And we are looking at that column, and we are looking at the data type of that column, whether it's varchar 2 with the specific size or whatever. It's immaterial. We just say %type and we get the value. And then finally we say index by binary integer. When we end up using a binary integer, then basically all the index values here are saved in base 2 inside the data, which makes for essentially better performance when we are trying to access the values in the index by table. So let's see one of these in play. Visually, you can see that we have a binary integer with a value set, and then we have column. The column we chose in the example was the column name we chose was the employee name. So it's a scalar value that, and each of the index values will have the corresponding name shown in the structure. So an index by table then is called index by table because of the index column that is automatically created with the definition. And like I said, this is dynamic in size based on the values that are stored. it's just like, you can simply keep adding values and the size will adjust automatically. You don't have to control the size by any means, essentially. So we'll see an example in motion here. So you can, we have got the employee name table that we mentioned, which is based on last name. We will also have the hire date table. So we are selecting, we're creating two tables, one with employee name and another with hire date. And because these are declared essentially using the percent type. So we will get the percent type for last name we get from the employees table, and in case of hire date, we just call it the date, or we could have chosen the hire date column in the employees table to reflect on this.
Oracle Arena tonight. The Warriors are getting ready to play. It's their final season over in Oakland, beginning a whole new season. Mark is there courtside. A lot of things happening tonight there, Mark.
So once, sorry, I think we were hearing some audio that is now most likely disappeared, and you guys can hear me okay, right, everyone? So we'll keep going here. So we've got our index by table declaration, and then for each of those we are declaring these two variables for the employee name and the. Now, how do we end up using the index by table? So we've got all these values or all these methods that we have. So next and prior allows us to iterate through the records in the table. So if we want to find the very first and the last record, we can use first or last property. These will return the first or the last value. And depending on where we are, we can go to the next to get the next value or the previous value. We can find the count of records in a table. We can also find if a specific element number exists in the table. And then last but not least, we can either trim a value or delete a value. So trimming basically will remove the value from the end of the table, and delete will remove all the elements. So knowing the difference between how trim works and delete works is very important. These tables will only exist during the course of the PL SQL block, and then they vanish once you exit SQL class. That's correct. There are some package level variables that you can declare that will make them more persistent beyond session. But for now, until we cover that, the answer would be that these would all disappear. So we declare a percent row type. So in this case, we declare a record or index by table of percent using departments percent row type, which basically will allow us to work with all the columns in the departments table. So the point is that an index by table can be used with either one value, which is also referred to as a scalar value, or it can be used with composite, which is basically more than one column. So in this case, in this example, you can see that we've got a type declaration using the employees table, and we create a employees table value set. Then what we are trying to do is we are trying to go through the loop 100 times and select one value at a time from the employee table into memory. So we are basically going to end up reading 100 we are going to start with 100 to 104, excuse me. So we're going to end up reading 4 records into the my EMP table. Okay. Because I mean, when you look at the syntax here, it says 100 ... p count. So 100 to 104, and it's going to I is going to start with 100, not 0. And I is going to start with a value 100 to 104. Okay. So counter is defined with this low value. That's right. This becomes the low value. Unless we say 0, then it will start with 0. Okay. So we select the rows, and then we go through all the names. So it says for I in my EMP table dot first dot my EMP table dot last. So we basically go through all the records, and in a loop we go in and we print out the last name of records that was basically read into memory. So we have the index by table. So essentially we have gone through understanding what is a PLC called record, what's an index by table, and what is a index by table of records. Basically, you can create multiple rows in a table dynamically. And we can also have the percent row type. Percent row type can be used both in creating a record and creating a table. So with that, you got your practice exercise 5. And before we cover this, I would like to just confirm the request I've made for working on assignment 5. So you're supposed to go through page 22 to 24 or completing the solution. So that would mean up to problem number 3. Okay. So let's look at those, because I think if I look at each of the practice exercise question, if there is something notable that you guys should know, then I can mention that for your reference. Yes, yes, including number 10. So in question number 1, it says, write a block of code to print information about a given country. So it's saying that work with the countries table and select and create a PL SQL record. This would mean that you would be able to use this will mean that you'll be able to select one record at a time, and then use the define command to pass in the country ID. You don't have to make the user type it in. You can just use a PL SQL substitution value. So based on the country ID that is provided, we basically go out and print all this, print all the column values, for the countries table for the named country, in this case Canada. So, and then you're expected to execute that procedure for these 4 countries: Canada, Denmark, UK, and US. Okay, so that's question number 1. Second one is based on the departments table. So it says that you want to create a PL SQL block to retrieve the name of each department from the department table. So in this case, it's asking for usage of the index by table. So again, you don't have to save the script in some .sql file. You can ignore this particular comment because we're not using the iSQL class. So what you do is you simply write this in your favorite text editor and execute the code. So you're supposed to create an index by table, and then select the contents of the entire department table into my department table, which will be a declaration you'll end up making. So it says that you have to write a loop in which you can retrieve the names of all departments for the given department IDs. So if ID is 1, for counter 1, bring department ID 10, and so on. And then it wants another loop to retrieve the department names from the index by table and print those on the screen. So you first then retrieve the names of all departments from the department table into the index by table, and then you print out the contents of the index by table on the screen, which would essentially look like that. And in the third question, even though it says optional, I'm requesting that you finish it. Because in the description I did ask for page 24 as well. So the block that you've written in practice 2, you modify that, creating an index by table of records, which will essentially mean that the by department table will store the number, name, and location of the department. And we will, so this time, instead of using just an index by table, you've got an index by table of records. But we are doing the same thing. We are retrieving data from the department table and putting it in the index by table of records and then printing the values of that. So this should give you an idea of what to do in chapter 6. What we'll do is take a 5-minute break, and when we come back, I would like to start you guys off with chapter number 6, which is working with cursor using explicit cursors. So resume in 5 minutes at 7:13 by this clock. Okay, thanks everyone.
Another sound quality check. Confirm. Okay. So in this 6th chapter, folks, can you all hear me? Okay?
Oh, you want me to speak louder? Okay. I will try. So in this chapter, we are going to focus on working with explicit cursors. Explicit cursors, cursor, as you know, is essentially a piece of memory that's allocated for processing query. So when you do a select statement, as an example, it creates a cursor automatically in the database. Those are called implicit cursors. But we can also create a cursor as a variable declaration, and the advantage of doing that is that we can then process the data inside a cursor using RPL SQL code. So in this discussion, we are going to look at the difference between implicit and explicit cursor and when are each of those created. We'll also talk about how an explicit cursor is created and used. And we'll also look at using a record variable for data processing within a cursor. And once we have looked at all of that, we will also talk about a new loop type, which is called a cursor for loop. So we have two types of cursors, implicit and explicit. Implicit are the ones that are declared automatically when we execute a DML statement. So whenever you do a insert, update, or a delete, then we create an implicit cursor. Also, when we work with a simple select statement, that also creates a cursor, implicit cursor. Explicit cursors are mostly created for when we want to maybe select one row out of n by using, and we can do that manipulation with an if statement, or we would use an explicit cursor for a situation where we will guys, some of you are saying you can't hear the audio at all. So we have the explicit cursor that would be used. We would use the explicit cursor for manipulating data for each row. And so syntax-wise, you guys are going to be able to see that in this slide deck. So this is what explicit cursor looks like. We will have cursor, which is essentially memory location. So cursor points to the very first record, And as we start moving with the cursor, we go through one record at a time. And that record essentially will contain whatever query was used for creating the cursor. So when you look at how an explicit cursor is created, we first declare a cursor that creates a SQL area. We then open that cursor, which essentially cursor is generally based on a query, some kind of a statement. And when we call the open command, it executes that statement for us. Yeah, it executes that statement for us. And then it points to the first record. It points to the very first record when you call the open statement. Then we start doing what is called a fetch, and the fetch would basically bring one row and make the second row as the most active row. And we can keep doing a fetch until the entire cursor becomes empty, which essentially suggests that as you go through the active record set, you will basically be removing rows from the cursor. And then once we have fetched all the rows, then it's time to go ahead and close the cursor, which will release all the memory for the cursor, and it will also get rid of all the rows that were in memory as a result of closing the cursor. You can go back and you can open the cursor again, but one thing you cannot do in a cursor is rewind and go back to a previous record. So opening the cursor means cursor pointer is at the very top of the cursor. Once we do a fetch, you can see that one row is removed from the cursor, pointing to the next row, which now is on the top. We continue fetching rows until such time that the cursor is essentially empty. And the fact that the rows are removed from the cursor as you do a fetch, then you can essentially see that the cursor, you cannot go back and rewind in a cursor. So the way the cursor is declared is using this statement. We define the name of a cursor, which is just the identifier name, and then we also provide a select statement based on which the cursor is declared. We do not include the into clause because we don't want the data added into some memory, because cursor is the memory, so we want to just use that memory for storing all the values as we do the fetch. So once the cursor has been declared, in this case we have two. We've got employee ID and last name, and then we have department in location ID 1. So once these two cursors are declared, then we can go ahead and use those. So another example, we have employee name, employee number, and employee name, local variables declared. And then we have employee ID and last name declared. So once this cursor is declared like this, we can start doing fetch of each of the row into these variables. But before we do a fetch, we have to go ahead and open the cursor, which will execute the query and bring out all the rows that are connected with that. So in this case, if employee table has say 30 rows, it's going to bring ID and last name of all 30. So cursor, once it's opened, will bring in 30 rows one at a time for one. You can bring in one row at a time for processing. That's why we don't use the into clause, because we end up doing the processing right here. The next thing we do is fetch clause, which basically would be fetch cursor name into, and then we provide a list of variable names or a record. So whatever the current record is, it will fetch the values of that record into the variable. Something like this. We will say fetch emp cursor into vemp number and vname. So the number of columns that are in the cursor, should be the same as the variable list that you end up providing. Unless you're using a %row type, then you can just say the name of that record. So to see the entire snippet I showed in plain one screen, you can see that we set server output on. In the declared part, we declare 2 variables. And then we also declare a cursor. Then we go ahead and open the cursor and run a loop 10 times. So Catherine, as you can see in this case, we start the loop at 1. And what we do in the first iteration, we fetch the cursor values into these 2 variable names, employee number and name. And then we simply do a put line. We're writing out the values, and we'll end up essentially running this 10 times. And once you are done with the cursor, you can go ahead and close the cursor. Closing the cursor will make whatever memory you have, that memory will be reclaimed. And by closing, you can go back and reopen the cursor if you need to process the data set again for some reason. So the point is that cursor is also a reusable it becomes a reusable variable. Sorry. So in the last example, the cursor is based on a select statement. So let me pull up the code snippet really quick for a moment. You see right here, you can see that we are selecting data from employees table, and we only have ID and last name. So cursor is not based on the table, but it's based on the query associated with that table. So, and I hope this answers the question you just asked, that Table does not have 2 columns. It's the query that does, and that's what we do. Okay. So once the cursor is closed, we can go back and reopen if we need to. These are some attributes of the cursor. Just like with the index by table, we had next, previous, and all that. All those were methods. There are some attributes. There are some attributes associated with the cursor here that tells us if the cursor is open or not, or if there are any values returned or not, and what is the total row count. So that's where percent is open, not found, found, and row count. Row count can be used. Percent is open is generally used by, it's generally used in conditions like this. You know, if the cursor is not open, then let's go ahead and open it. Okay? Because if it's already open and you try to open a cursor that's already open, it may just throw it may throw an exception. So then after you open the cursor, it's a good idea to use the row count to see how many rows are impacted by the cursor. And then this way you can control the loop. You can control the number of times you may have to loop through. So what we are doing is bringing in one row at a time, and we are going down the cursor one row at a time. We are not again moving around the table, Catherine, because what we are doing is we are taking a copy of we are running a query. When we run a query, we open and bring out the rows in memory inside the cursor. So you won't be modifying the table at all. You'd just be using the column names that we have created in the cursor by the selecting tool. So you can process several rows, fetching one at a time, and you can use statements like found or not found to test the success of each fetch. So I think rather than talk about it, it will be nice if we could give us examples of how these are. So Catherine, is your last question answered? Where you say if we have a cursor to move around the table, does this mean indexing would not be necessary? We are going down on the cursor one row at a time. We cannot go backwards. So given that, we don't really need to use any index whatsoever. And we're also not going to use an index by table here. We're just going to use the record to work with one value at a time. So here is an example of how percent not found can be used. So in a loop, we go out and if we want the loop to be an event-based loop, we go out and fetch the first row. And if no not found is returning true at that point, then we would basically terminate the loop. So usage of percent not found. And we can use row count as a condition to essentially control how many rows like if how many rows do we want to add. So when a cursor is open, percent row count is basically 0. And then we start fetching values, and each time the number with each fetch, the value is incremented by 1. So in this case, if we want to only do something after fetching 10 rows, then we can put this condition in place. We also have exceptions that we're going to talk about eventually, but here is that example put together completely. So as you can see, we've got our two variables declared up on the top for employee ID and employee name. Then we create a cursor. Then once the cursor is declared, we go ahead and we go ahead and open the cursor. So we open the cursor, then we create a loop, and we fetch the 1 value. At this point, row count is 1 after this fetch. So because row count is 1 and it's not greater than 10, or it's not the end of the cursor, one of those conditions has to be true. We'll go ahead and print out the values of the first row we did, and then we'll go back into the loop. So if I gave you guys this as an exam question to state how many times is this loop executed, then the answer would be either 10, or if there are rows less than 10, like 8, then it will just run those many. It will run those many number of times. Now, doing all this is a lot of work. Declaring a cursor, declaring variables for saving values for each row in the cursor, opening the cursor, and fetch statements and close. So they did talk about an easier way of shortening the number of records, and that's in a cursor for loop. So this is the last topic in this chapter, and what we do is we create a record name. So and we use the name of the cursor. In this loop, it automatically detects the number of rows that are in the cursor and processes the loop. So you don't have to open, fetch, exit, or do a close, because this loop ends up doing that for us. So it's far less amount of code that we have to write. So we declare our cursor like we did last time, but all the variables like emp record automatically becomes the type of emp cursor. So whatever columns we are selecting, whatever columns we are selecting in emp cursor, emp record becomes that. So then we can write our statements inside, whether it's an if statement or what have you. We say if emp record or department ID is 80, then do something. And then when we end the loop, that will implicitly close the cursor. So the nice thing in this for loop is that you end up writing far less code. So we say we just declare the cursor, and when we said emp record in, when the control gets here, the loop is, the cursor is automatically open. So for does all the housekeeping of open, fetch, and close. So then we say if employee record is, if employee record, if department ID is 80, then we can just say that employee name works in the sales department. Okay. And then so we'll read maybe a bunch of records, but when department ID is 80, we'll print out the data. And then we go ahead and we close the. We can put a subquery inside the for loop. So if you don't even want to declare the cursor like we were in the previous example, you can just define a select statement and then start the loop, which makes it even easier because you're working with a query on the fly to deal with the data. So in this example, which is we've got 4 variables: employee ID, job ID, start date, and end date. And in the cursor, we end up selecting those. And we order the data by employee ID. We then go ahead and we open the cursor and fetch the first row and print out the value. And the fact that we say exit when row count is greater than 4, we end up basically closing the loop. So this is how we can process the first 4 records. So we've talked about the cursor for loop, which I think is probably going to be the most popular thing for your next exercise. So in the next exercise, to confirm again what I'm asking you guys to do. In assignment 6, I think you're also working on all the optional assignments. So you're going page 27 to 30. So we've got three problems. Three problems that you are going to end up solving. Now, each of these questions will obviously require you to write cursor code, and I would say that both 5 and 6 will be little coding intense exercises. So first one, you just create a table, and so you can either run the script or just that script is you don't have to put it in its own SQL file. You can like I said earlier, you can just call. You can just put the code in one simple select statement, one simple text file to submit. That's where you can have your queries and also the stored procedure definitions and showing the output. So the next question is writing a block of code to show top employees with respect to salary. So you need to prompt the user to enter a number like N, so you can get top 5, top 10 earners. Then we take that value in a substitution variable and then go to the employees table, create a record, and print the information of those employees in the table created in number 1, and then write a cursor to show the output of the 5 salaries. I think you guys will enjoy these exercises because now that we've got some coding flying into these, into the exercise. In the third case, you have to create a PL SQL block to retrieve last name, salary, and manager ID of the employees working in a department. And if there is some criteria, if an employee makes less than 5,000 and the manager ID is either 101 or 124, then display employee name is due for a raise. Don't forget using set server output on and for being able to see the values of like when you execute the procedure, you can see the output of the procedure when you have set server output. Okay. So that is all for today, guys. And our next chapter is going to be lesson 7. I noticed that the due dates for assignments 5, 6, and 7 were not lined up properly. So I just adjusted those to make sure that they are sequenced. So you guys have plenty of time to work on those. So I did update those dates this evening. Have a wonderful evening, everyone, and I will see you all same time, same place next week. Thank you. And I'll post the recording later tonight or in the morning on your Canvas site. Good night.